Hello Math 1B, I got a new lesson for you. It's using prime factorization, the stuff we talked about from 5.1, to find the greatest common factor between multiple, I guess we call them monomials, right? Yeah, multiple monomials. So, if this projector happens to go out, I'm going to keep filming the video. It did that to me on my last video. So, let's get to it. All right, so I have a specific strategy for finding a greatest common factor using prime factorization. It's not the only way to do it, but it's the way I'm wanting you to do it on tonight's homework. So it should look like this. Otherwise, I might not give you much credit for it. So the greatest common factor between one or two or more monomials, or as you'll see later on, polynomials, is the biggest quantity that they both can divide out. So, for instance, like 18 and 27, the greatest common factor between these two can be determined by doing the prime factorization for each one of them. So 18 is 2 times 9. That's 3 times 3. So you get 2 times 3 times 3. Got it? Yeah. Now 27 breaks down as 3 times 9, which is also breaks down to 3 times 3 times 3. Okay? Now the greatest common factor is the biggest number, that they all divide. So they both divide 2 sets of 3s, but as you can see, those 2 sets of 3s can also be written as 9s. So the greatest common factor between 18 and 27, the biggest number that they both divide evenly, is going to be 9. So that's the strategy I'm going to have you guys try out today with these 4 examples on the notes and then the problem set as well. So jumping into number 1. I've got 42xy and I've got 56x squared y. My biggest task at this point is to use the factor trees to break down 42 and 56 to their smallest prime parts. So what does 42 look like? Well, it's even. So take half of 42, and you can use your calculator on this. Half of 42 is 21. After I've exhausted all the even numbers, maybe I'll try 3. And I happen to know that 21 is 3 times 7. So prime, 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 those 3 numbers now make up 42. So 2 times 3 times 7. Notice the 21 is not a prime number. It's not included for the prime factorization. Make sure you put times x and y on the tail end as well. The variables count. All right. 42. Got it. How about the 56? Well, it's even, so I'm going to cut that in half. Half of 56, I happen to know that's 28. 28, half of that's going to be 14. That's even again, so keep cutting it in half. Half of 14 is 2 times 7. Looks like we've got a familiarity with the 2 and the 7 for sure, right? So 56 is 2 times 2 times 2 times 7. There's xx for the x squared, and there's 1y. So here's how you map out the prime factorization. Now you circle what they share. They share a pair of 2s. They share a pair of 7s. They share a pair of x's. They share a pair of y's. So what is the greatest common factor among these two? 2 times 7, which is 14, times x times y. Let's try this with number 2 now. So I'm lining it up horizontally. Now they're both negative, so I'm just in case I forget, I'm going to put the -1 right away for both of them. So 64 and 27 are the two numbers. We already did 27. We knew that that was 3 times 9, which is 3 times 3. So maybe I can do this one first. 3 times 3 times 3. And then C, D, D, D. $64. You know what? I know it's 8 times 8, which is very tempting to do the 8 times 8. I see even. I'm just going to cut it in half so that my prime numbers are always on the left. Half of 64 is 32. Still even. Half of 32 is 16. Still even. Half of 2 is 8. Still even. Half of 2 is 4. Still even. Wow, it's just a bunch of 2s. So I don't take into account the non-prime numbers. Only the 1, 2, 3, 4, 5, 6 pairs, or not 6 pairs, but 6 2s. So 1, 2, 3, 4, 5, 6, and then AA for the A squared times B. All right, they share a -1. They don't share any 2s or 3s. They don't share any A's. And they don't really share any B's either. Or C's. Or D's. That's it. Just the -1. If the GCF is 1 or -1, it's got a special category for it. If the greatest common factor, this is something you should put on your notes. If the greatest common factor is only 1 or -1, oh, you know what? I think that's for the next lesson. I'm not going to finish that statement. I'm just going to put a ... and say it's a special case. That will be named at a later date. Okay, first 2 examples done. Why don't you guys pause the video and try number 3 on your own. It's up at the upper left-hand corner right here. All right, you got it? Let's check out the answer. 16. 16 ends up being 2 times 8, which is 2 times 4, which is 2 times 2. 1, 2, 3, 4 2s don't include the actual non-primes. So this is 2 times 2 times 2 times 2. M's, there's 3 of them for m cubed. N squared, there's 2 of them. -48. Well, there's a -1 there, so don't forget that. 48 is, half of that is 24. 24 is even, so you can keep cutting it in half. Half of that's 12. Still even, cut it in half. Half of that's 6, cut it in half, still even. And now we're down to all primes. So not a prime, not a prime, not a prime, yes a prime. 2 times 2 times 2 times 2 times 3. So we got our -1. 2 times 2 times 2 times 2. There's 1, 2, 3, 4 of them. Times 3. There's 5 M's and 4 N's. 1, 2, 3, 4, 5. 1, 2, 3, 4. All right, so the greatest common factor. They share a 2. They share another 2. They share another 2. And another 2. So this is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. For the variables, 1m, 2 n's, 3 m's. m to the third power. They also share an n and another n to the 2 power. So check your work. If you had 16m cubed n squared, you are correct. All right, last one. We've got 3 quantities instead of 2. So I'll do one example of that so you guys aren't lost on the homework. The only difference here is that all 3 of these now must share a factor. Not just 2 of them. All 3 of them have to share. So what does 108 break down to? Well, half of 108. I just happen to know that that's 54. Still even, so cut that in half. That's 27. We just did 27. It's 3 times 9, which is 3 times 3. So that's going to be, only count the primes, 2, 2, 3, 3, 3. 2, 2, 3, 3, 3. And then XX. All right, check out 39. Well, that doesn't divide 2, but it does divide 3. Ends up being 3 times 13. Both prime. You can't do anything more with it. And then y squared, well, x cubed y squared is xxxyy. And then 51, make sure you put a -1 on there. That divides 3 as well. It's 3 times 17. 17 is prime. It's done. And then there's 3 y's. So all 3 of them share a 3. But they don't share anything else. Okay, we can't start saying, well, these 2 share an x, and these 2 share y's. We have to just stop right there. That's all that all 3 of them share. So the greatest common factor is 3. All right, hey, thanks for watching, guys. I appreciate it. Hopefully this lesson goes fairly smoothly for you. You're just doing prime factorization and then identifying all the shared parts. See ya.